Okay, security wiring systems. Okay, so this was introduced in Amendment 3 to the wiring regulations for wiring systems to be secured against premature collapse in escape routes. Okay, to make sure that in the event of a fire, there's no less entanglement issues for people escaping buildings under fire, or of course firefighters getting in the building to help people to escape or get out of that fire. So they introduced things like metal clips inside plastic trunking, so over escape routes, over escape doors, in escape areas, corridors and things like that. We had copper clips, copper saddles and things, metal clips, metal saddles to actually hold cables in place in the event of a fire. So it's pretty much the same as in the 18th edition, but there was obviously a lot of debate about what is an escape route. Okay, to get to an escape route, you might have to pass through a majority of an area to get to that escape route. So to make that a little bit clearer, I guess, and to take away that bit of confusion, they say, well, take away the word escape route and it means wiring systems shall be supported. So all wiring systems now need to be supported against premature collapse in the event of a fire, whether they be an escape route or not. So that will include now for the increased use of metal clips, saddles, and other containment. Buried cables. I was actually a little bit surprised by this myself when I read this as a new edition. It used to say about burying cables against protection against the foreseeable disturbance of the land. And it didn't include for SELV cables, and now it does. So if it's a SELV cable, it doesn't matter what the voltage operation of the cable, we have to do the same requirements, which means we bury it at suitable depth, we cover it with cable markers and tapes and things like that. Overcurrent protection devices in 531.2, just to clear up some points and some misunderstandings that are going around. Is it a requirement now that we switch to neutral in overcurrent protection devices? No, it isn't a requirement that we do that. We still have single pole MCBs, RCBOs, etc., and they are suitable for most installations. Okay, there are a couple of special locations in Part 7, caravan parks, marinas and places like that, where it is a requirement to switch to neutral or switch both live conductors, but in general installations, whether it's TN or TT, there is no requirement to switch to neutral. Single pole switching with single pole devices is still acceptable. Now, this is something we need to be getting used to with the 18th edition. Types of RCDs, and by types I don't mean 30 milliamp, 100 milliamp, etc. Okay, so this regulation has introduced different operating types of RCDs. Okay, so from where you might be viewing this video, those two RCDs look absolutely identical. They are both 25 amp RCDs. They are both 30 milliamp RCDs. Where they differ is the type of residual current they might be able to detect and respond to. So mostly up to today we have type AC, which are general purpose RCDs. Now these can detect and respond to AC sinusoidal waves only, a pure sign changing or direction changing AC waveform. The one on the right, however, is a type A RCD. Now what this can do, it can do the type AC, it can do what the type AC device can do. In addition to that, it can detect pulsating DC currents. So after electronic equipment's been installed, we might not get a pure sinusoidal sign changing residual current. We might have a pulsating DC type of residual current. So this device can detect to that. Moving on, we have type F RCDs, which can detect the AC, the type A, but in addition to that, it can also detect higher frequency residual currents. And the last one, probably the best one you may say now, is a type B. It can do what an AC does, it can do what an A does, it can do what an F does, but it also now can detect and respond to smooth DC current, which might be useful for electric vehicle chargers, PV supplies and things like that. So these are the four types in general use, or four types that we'll be getting more used to. And you can see on the right hand side there, they're the kind of symbols we might see on the product or in information, instructions and documentation. So why are we now having this? So let me just try to explain this if I can. So the equipment in the dotted line now is showing a typical piece of electronic domestic appliance. Now most of our domestic appliances these days, a washing machine, dishwasher, have got some kind of electronics for the control systems in the machine. So The supply to the machine, of course, is a 230 volts AC supply. So let me, for example, say that if you had a fault there, whereas the cable comes in to the machine, and you happen to be touching the casing of the machine, it is a class 1 machine, of course, you will conduct electricity and you will receive electric shock. Now, if we can see what that voltage and current look like, we will see it as a pure sinusoidal sign changing waveform, which a type AC device can detect and respond and trip and disconnect in time to stop the any further issues with the electric shock. However, should the fault be internal to the machine, now after the rectification part of the machine, because obviously electronics doesn't work on AC, it works generally on DC, if we can now see what that electric shock voltage and current looks like, it won't be a sinusoidal waveform, it will be a pulsating DC waveform, because going through the diodes it cuts off the negative half cycle, could cut off the negative half cycle. Now if that was a type AC RCD, it either may not trip at all or may trip in a significantly longer time, both of which are undesirable, of course. A type A device therefore is required in this instance. Now I said that most domestic appliances that we have nowadays does need electronics in order for its control systems. Look at some instructions of this one, particularly from a Bosch dishwasher. Okay, there's a little clippet of information that I found in the instruction document. So any person going into like just a retailer or something like that and buying a dishwasher, a washing machine, whatever it may be, okay, may read the instructions, but those instructions usually about the wash cycle, what I need to put in it, stuff like that. Okay, they don't really look into detail on the technical information. So buried in probably page Z of this information for the this dishwasher was about the RCD that should be feeding this equipment, and you can see the symbol that is required on the RCD, so to give adequate protection of this equipment and persons using this equipment. So appliance manufacturers are getting more savvy with this concept, of course. We as an electrical distribution need to get more savvy and actually provide this protection. We're trying to make it easier as the manufacturer, of course, so we will be making and defaulting more to type A RCDs than type AC RCDs. At the moment, if you buy just a consumer unit from us, or it probably would have 2 RCDs, which probably will be type AC. In the very near future, you may or may not even observe it, but they will be 2 type A RCDs. The RCBOs, the shorter RCBOs we introduced some time ago now, have defaulted already to type A. So we will be kind of merging away from type AC RCDs and towards type A. Should some information or extra information be useful or interesting for you to access, Beamer actually produced a lot of really good guides on different topics, and one of the latest ones, of course, is on the types of RCDs. So if you want to access these, are all free of charge, beamer.org.uk, you can get all these technical guides, and it gives you all this information about RCD types. There's one on AFDDs as well, and many other subjects. It is a really useful method of obtaining technical information.